Hold on, don't start yet. Don't start yet.
Okay.
Okay, so we have 2 minutes. You might need an extra second. Yeah? Okay. Ready now? Are we ready now? Okay. All right, 2 minutes. Look. Don't even start. Ready? Go. People being rude. Here we go. Y'all okay?
That's my alarm thing, and so whenever they go off,
I know, I'm with you. Alright, so you got your notes on your desk. So we're starting chapter 3, and what is the very first thing that we are learning today? At the end of chapter 3, yes. Not right now. What are we going to learn first?
Percentages.
Read, child. What's it say?
Graphing.
By graphing, right?
I know how to graph.
You probably need 2 different colors. So if you've got like a pen or a highlighter or something, and then your pencil, not your phone. All right, here we go. So we're gonna do some graphing first. Sorry, get used to it. It's gonna be there forever. We're not getting away from it. But Isaac chapter 4 you might like because there's no graphing in it. Yeah, but then we'll be back to it in chapter 5. So, all right, where we at? All right, on the back of that, here we go. So, what is the title of 3.1? All right, and we have to kind of catch up a little bit before December gets here, and we're going to catch up a little bit today. That's why I haven't given you a calendar yet, because I'm not really sure how much y'all can handle each day until we get there, and then I can see what y'all are doing. So, not that y'all can handle it, you're smart, but y'all know what I mean. Stop it. All right. So, what has 2 or more equations with the same variable? What's it called?
Equation.
What kind of equation?
A system.
System. There you go.
That was a wild guess.
All you gotta do is read the title. It's always in the title. All right, but this is different. So you got a system can be classified by the number of solutions, and there are 3 different types. You got one, and this, especially if you're visual, you might want to do this at the top up here. You got one of them where it has 1 solution. Why does it have 1 solution? Because it crosses at one point, Jesse. Perfect. You got one that looks like this. You've got one kind that is the same line. So you got two equations. So like this one, let's see, 2x plus y equals 3, and y equals negative 2x plus 3. Are those the same line?
Yes, ma'am.
Why?
Because you just flip the side.
You just change the 2 over here to the other side and it'd be the same thing, right? So these are called infinitely many because every single point that you do is going to be the same. And then you got one more where they're parallel lines. Those have no solution. Why do they have no solution? Because what's going to happen to those graphs?
They're going to keep going.
They're never going to intersect because they're going to keep going forever. They're going to just be parallel. All right, so here we go. A system is consistent if it has at least one solution. So this one has one solution, so we're going to call it consistent. Yep, this one right here. This one has every single dot there is. It's called infinitely many. So this is also consistent. All right. And it's called inconsistent if it has no solution. So the parallel line is inconsistent. If you're visual, you really want to write that those three graphs at the top. It makes it easier to see than reading through all that stuff. All right, so if it's consistent, so only if it's consistent, then it can be independent or dependent. There you go. Yep. And so if it crosses at one point, it's consistent and independent. And if it's the exact same line, it's consistent and dependent. Because one depends on the other to be exactly the same. You're all okay? What? You got it?
Yeah. That makes sense.
Bless you. Mario, all the way in the back, though. And I'll be with you in just a second, okay? All right, if it has exactly one solution, then it is
true.
Hold on. I left my blanket around side and now I'm kind of lost my little count. Oh, well, I just went ahead and gave it to you. Okay, I see what I did. All right, if it has exactly one, it's called independent, which we already wrote on our graph up there. And if it's infinitely many, then it's dependent. So, do you remember when we did functions and we called them one-to-one or onto functions? Get off your phone, please.
Yes, sir.
Okay. So, if it was a function, get off your phone, please. Somebody call you out, please. If it was a function, then you went on to say if it was one-to-one or onto, right? But if it was not a function, we didn't call it anything. So it's the same thing here. If it's consistent, then you either call it independent or dependent. But if it's inconsistent, you're done.
Right.
Good? All right, let's do some graphing. Here we go. In order to graph, what must first happen?
You have to get it in.
There you go.
Yeah.
And if you're like very visual, this is where you might want to have your two different colors. So let's do the first one. This is rising or it's negative. Negative. Alright, so here we go. So we're going to subtract the x, so we get 2y is equal to negative x plus 6. Y'all okay? We're going to fly today, so you got to tell me if I'm going too fast. And then divide by 2. Negative 1/2 x plus 3. Let's graph it.
We are going.
I'm not doing anything.
Oh, right.
I'm waiting on you. Alright, here we go. We're going to go up 3. And we're going to go down 1. Bless you. And right 2. Alright, you want to go all the way as far as you can go. Because if not, you may not see where they cross if you don't go long enough.
Wait, up 2?
Up 2 or left 1. Yes, sir.
Up 2. So why do you
It's the exact same thing as piecewise. You're just doing the whole thing. You just don't have to determine which piece to take. No, it says identify the type. Like there was 3 parent graphs. Tell me what type it was. Alright, so since it has an equal sign, what kind of line is it always going to have? Straight, what we called it, a closed line. Yep. Since it doesn't have an inequality, it doesn't say less than or greater than, so we're not going to shade anything, okay? Alright, let's get to our different one. So we got 2x plus y equals 9. All right, we're going to subtract the 2x. So you get y equals negative 2x plus 9. And I don't think we have enough room, so we have to go up one extra one to get 9. All right, y-intercept is 9. Slope is negative 2 over 1, so we're going to go down 2 and right 1 as far as we possibly can go. And when you go down far enough, what do you notice happens? They cross at 4 and 1. All right, so 2 things you have to tell me. First of all, it wants you to describe it if it's consistent, independent, consistent, and dependent, or inconsistent. Which one is it?
Consistent.
And?
Independent.
Independent, there you go. Then, I need you to tell me the point where it crosses. Where? 4 and 1. Beautiful. All right, let's go to the next one.
Great tacos.
All right, same thing. You think you can try this one on your own?
Yes.
All right, you try number 2. Go.
Oh no.
Mario, do you have your test already? What are we doing? Okay. All right. Checklist for maybe beginning of the year. Very beginning of the year. How you have to do this. It says test correction procedures, something like that. Did it? Okay. And then just follow those directly. Okay, so you get all your points back.
Uh-oh.
What?
I feel like it's parallel.
Is it?
I think so.
Okay, well, let's see. 1, 2, 3, 4, 5. Well, how before you even graph it, you should know if they're parallel or not. How? There you go, Brent. They have the same slope. Very good. Once you solve it,
It could be a million years, but eventually it's going to cross it.
not if they have the same slope.
Not if they have some.
So they do have the same slope, so they will never cross. Man, those are really close together.
I know, they were round now.
I know it. I need to change that for next year. That's not. Very good. There we go. Okay, so what do we call that? Inconsistent, and you're done. There's no point where they're ever going to cross. There's no way they can ever be independent or dependent. And let's flip to the next page. Go. We got 2 more. I told you, we're flying today. We got to get caught up on those 2 days.
What we gonna do with Maria hits?
If what?
Maria hits.
We're going to cross that bridge when we get there. I might have to take out some stuff in chapter 5.
Well, there might not be a bridge to cross.
Well, that's true. All right, 3
That
and
was
4.
a good one.
Try 3 and 4. 3 and 4.
That's what she said. Yeah, possibly.
I mean, you're a teacher.
Colorblind, so
Okay.
what?
Really?
Yeah.
I just not finished 2.
All right, let's go 3. Come on.
Thank you. I'm so glad we don't have to worry about it just an open dot. You don't have to worry about it. There's nothing about it. Such a pain. I know what they cross at.
Anyway, here.
I mean, it didn't happen, but what if they don't want to exactly cross at a point?
Right.
Oh, what if they cross like in between?
It's just a decimal, but I won't give you one like that.
Oh, okay.
I mean, if I did one like that, it would be like at 0.5, something like a good decimal.
0.00124.
Yeah. Can you do this on your calculator?
Yeah, but you still have to solve it for y first.
Ma'am?
Yeah, but you still have to solve it for y first.
Okay, I'm sorry.
Did you do both of them?
Yes. Oh, no, not those.
Oh Lord, it's all off that line. Pretend like that's actually on those dots.
I do that in. Oh, it's another parallel line. Wait, they're both the same.
No.
Yes. So it's going to be that consistent dependent one.
Mm-hmm.
Right, that's a negative, so.
Oh gosh. So I didn't put my -2. Golly.
Dang it, Miss Whiteman.
Dang.
I was looking.
Urgh, fudge nuggets.
Wasn't that deep, Miss Whiteman?
And it's positive. Stop. Gosh. Oh, look at there. It still crosses at the same point.
Yeah, that's what I was
Like, it's
I got
not,
it wrong.
it's not that big of a deal.
I would have gotten a -1 on my test. Can y'all read through my gibberish for that?
Yeah, you're
Okay, don't look at that one. That one's not right. Okay, so since they cross, then what do we call it? There you go. And when they cross, I need you to give me that point because they do put these on the ACT, and mainly what they ask you was where do they cross. So let's make sure we're okay with that. Where do they cross at? 4, 0. Very good. All right. What about 4?
It's a tricky one.
Why? Oh, they come out to be the same?
Yes.
Okay. Hold on. Let me make sure I can do my math this time. What?
We're amazed at how you taught it.
Do you like math?
Huh?
Did you like teaching math?
Do I like what?
Teaching math.
No, I just went to school for 8 years just because, you know, I wanted to do math all
Could have been
day.
a doctor by then, Miss Whiteman.
Yeah, I know I could
You're a
have.
doctor.
I know I could have. But I didn't. I'm here with y'all because I like to be. Because we're making all that money. Like you
Shoot, I would have
said.
been making the big bucks before
All
you
right.
went to
So,
school.
so they became the same line, right? And so what do we call that when they become the same line?
Consistent dependent.
Consistent and dependent. Very nice. Very nice. Very nice.
Did you ever think about being a doctor?
Actually, I was an engineering major first.
Ugh.
And then-
Could you be like a petroleum engineer right now and make like $400,000 a year?
Yeah, but they have to move a lot. They move a lot. All right, so let's look at this, guys. Let's make ourselves a note. Or do we have any questions on graphing? Are y'all okay? Yes, ma'am. No. Not unless it asks you to, which most of the time it doesn't want you to. It just wants you to write this, which tells me that it has an infinite number of solutions. All right, so make yourself a note right here on substitution. So when you go to the store, don't write this down. But let's say we go to the store and we have $10, right? And you want to ask the cashier to make change for you. So what can the cashier make change for you out of $10?
She can give you 2 5s.
She can give you 2 5s, 10 1s,
10 1s, 5 2s.
5 2s. What are the odds of her actually having 5 2s though? So you can change them out, and they're going to look really different, but they're going to mean the exact same thing, right? So it's the same thing on substitution, and all of this is still a review from Algebra 1, guys. Okay? So you can change, instead of x, what can you put that x equals? Yes, ma'am.
I'm sorry to interrupt. I have a parent here who needs to purchase some homecoming t-shirts. How could I do that?
They'll have to wait till Monday during lunch.
Monday during lunch.
And they go
okay,
up.
Thank you.
They go up to $15 next week.
I think so.
Oh well, be all right. Okay, so do you see an x in the other equation?
No, ma'am. Wait, yes.
Yeah, right here.
Sorry.
All right, so we're gonna write 3, but we're not gonna put x. We're gonna change. We're gonna substitute what x equals, and we're gonna write -5y plus 3. And then we're going to keep going with our equation. Minus 2y equals -8. Yep. This is just a review for algebra, okay?
Why do we do this?
So, because now, look at what they both have y, so now you can figure out what y is. Alright, so we're going to distribute. It's just a different way. Instead of graphing, you can do it this way. Sir?
Ms. Blackman, they're an employee that's not on campus all the time. Can I just take it?
Oh, like they don't have a student, it's just them?
It's not a student, they're an employee.
Oh, yeah, sure. Just take it, and I'll have to get it Monday, though. Just make sure you get what size they want, please.
Okay, but we can do it in today's price, right?
Yes, ma'am. I thought you meant they were buying it for a student.
No, I didn't know at the time I first called them.
Okay, thank you, Miss Davis.
I'll fix it.
Okay. All right, where are we at? So, like, look, the whole reason we did that is because now we can figure out what y is. So we can say -15 minus 2 is negative. Yeah.
That one, right?
And then we're going to subtract the 9. What? Oh, that's why you just added the 9 is all. So subtract the 9, and that would be -17. Divide, and y equals 1, right? But we're not done yet.
Oh, great.
Because
We
the
have to
whole,
plug in.
there you go, because the whole point of doing this is so that you can find out where they cross without actually having to graph. 'Cause
Yes.
if you don't like to graph, it's the exact same thing. Yes, ma'am?
Can we please have Kayla Shaw to check out?
You're killing me, Small. Yes, ma'am.
Thank you.
Okay. Bye. Wait, are we doing a lot?
Probably why she started laughing all of a sudden.
Yes, sir. So the only thing that we found so far is the y value, right? Now we've got to plug it back in to find the x value. You've got 2 equations. Does it matter which one that you plug into? No. But what's the easiest one to plug into?
The one where the x is by itself.
There you go. So let's plug into this one. So we have -5y plus 3, but I'm not going to put y.
You could plug it into the other one.
You will get the exact same answer. Yes, sir. Exact same answer. It's just going to take you a little bit longer because most of you could plug this in your head and give me your answer. Bye, Kayla.
Bye, Kayla. Have fun in Kentucky.
So your answer is -2. Why didn't you leave earlier? Yeah. Oh, okay. Bye. Be careful. All right, so if you were to graph those, what would happen? It would cross at -2, 1. So if it asked us if it was independent, dependent, consistent, and inconsistent, what would we call this one since they're going to cross at this point? And which one? Independent. There you go. All right, let's look at number 2. Number 2. How is number 2 different than number 1?
Because you have x and y on both sides.
Yeah. So what did we look for on number 1 that we can make a note for ourselves about substitution?
Look for the x.
Look, not for an x, for a letter by itself, because it's going to be either one of them. So make yourself a note right here on substitution, okay? You ready? Make yourself a note. Make yourself a note. when it says solve using substitution, just like our learning target says we're going to solve with substitution, you have to look for a letter by itself. It doesn't matter which one, just some letter by itself. So on number 2, you don't have a letter by itself, but you can make a letter be by itself.
So if we were to do number 1 really complicated, we could have got 3 if it did 3x by itself. I mean, it would have
Yes, it would have been very complicated, but you could have done the same thing. Yes. All right, number 2, the easiest one to work with is going to be the bottom one, right? Because the x and y don't have a letter. I mean, I don't have a number with them. So it does not matter. Which letter do y'all want to solve for? And solve for x, okay? You will get the exact same answer, guys, if you solve for y. Well, you get your answers backwards, but you get the same thing. Negative y minus 12 is our answer. All right, so we're going to take what x equals, and we're going to plug it, and we're going to plug it in for x. Yes, sir.
Trying to see where the negative y came from.
Because we subtracted the y over to the other side to get x by itself. All right, so we've got 2 parentheses, negative y minus 12, minus 3y equals 6. And the whole point of doing that is because now the only letter we have is y, so we can solve for y. All right, combine your like terms, you get negative 5y. Add the 24 over. Yep. Divide. And you get negative 6. So you have 3 equations to work with now. You've got the 2x minus 3y equals 6. You've got the x plus y equals negative 12. And you've got the x equals negative y minus 12. Either one of those 3 will work. Which one would be the easiest one to plug into? X plus y equals negative 12 would probably be the easiest one. So we're plugging the negative 6. We're going to add it over. And what's our order pair where they would cross?
Negative 6, negative 6.
Perfect. So if we were to graph those, we'll get the exact same answer. So if you like to graph, you could graph instead. And what would we call those? What if they're going to cross at one point? What do we call them?
Consistent.
And
Independent.
there you go. All right, let's flip. Let's keep.
Oh.
Come on, we got a bunch of stuff to do. All right, 3 and 4. 3 and 4. It said to solve using what?
Hold on, this black one, you said it was consistent at first.
They would cross at that point, so it would be consistent and independent, just like number 3 is right there above it.
Oh, this one's
Keep going, number 3, where you graph. Just like that one.
What about number 1?
It has a point where they cross. You count the point, so that would be consistent and independent. Yes, sir. All right, so y'all try 3 and 4. Now look, guys, 4 has A and B. So how do you know which one's X and which one's Y? Like, how do you know what order to put them in? Very good. Alphabetical order. A would be in the X spot. B would be in the Y spot of your order pair. All right, y'all try 3 and 4 real quick. Y'all try 3 and 4.
Nice. How could you get one that's consistent?
Just why we wait and stuff.
Yeah.
Just trying to make sure I set it up right. Isn't that right? Right there. Oh, so it has to be this time.
Yeah, but it must be right. So it doesn't have to be on that side. It just needs to be nothing else in it. You got the negative 3y and the negative 3y. So you put that separate.
So it'd just be easier just to switch the top one.
Yeah. Yeah, it would be easier because that X is almost by itself on the bottom one. This X on the 3 and all that good stuff in it.
Wait, hang on, Miss Bobby.
What?
Okay. I have a question.
Did you have a question? Yeah. No, you're saying on your phone.
Okay, I have this. What do I do?
Yeah, now you're gonna plug this
Oh.
in for X.
X right here.
No, that's the one you call. Yeah,
Yes.
that's the one. See it? Alright, now find one of those. One of those is gonna solve for a letter. This one's probably gonna be easier with extra on the side. You can watch out. See, after the but that's okay. After this problem, we'll divide by that negative. Change is not a mistake. Yeah, that's true.
You subtract 9 minus 9y. Like 9y minus 9y would be 0.
Yep.
Okay, so what's this supposed to be 0? Okay.
But what's left, you don't have to write the zero, there's something else left there.
It's just 18. So it's no solution.
No, they equal each other.
I know.
Yeah, they do, 18 equals 18.
I got 18 equals 6.
I think 18 equals 6.
Oh, wait. Wait. I know. So we have 18 equals 13. Terrible.
Trying to do too much in your head, try to work it out without.
Alright, which one did y'all work out on number 3? The top one or bottom one?
Top.
I worked the top one?
I worked out the bottom.
I'd probably work at the bottom one. So, like, you're going to add that 3y over, right?
Oh, that's what you meant. Never mind. I worked out.
And that would be negative x is left. And then divide by negative 1, be negative 3y plus 6. So this is what we're going to plug into the other one. So we got 9y plus 3, negative 3y plus 6. So 9y minus 9y. Where are you confused here? You have to get that note we wrote on substitution. You have to get a letter by itself. Which it looks like you did on paper.
Yeah. I did x equals negative 9y plus 18.
You should get 3x equals negative 9y plus 18. Then you divide by 3. That does not say x, that says 3x. Yes, so when we get finished with this, yes. Alright, so these equal each other. These equal each other. So what do we call them when they're actually equal to each other? All real numbers.
Oh!
And what kind of a graph would that be? The consistent and dependent. It would be the one straight line. They were the same thing, okay? Alright, number 4, what'd y'all do? Which one did you get by itself? Top one? Okay, so you got A equals positive 3B minus 22. And we're going to plug that into this guy. So distribute. 12b plus 2b is 14b. Add the 88 over. What is that, 6? Alright, and then we're going to plug that in. Which one do you want to plug into? This one?
First one.
That one?
Yes, ma'am.
Let's plug into this one where it's already solved. That'll make our lives easy.
Okay.
But you'll get the same answer if you plug it in here, though. You just have to take an extra step. I'm just going to be lazy. Y'all okay? Jack, I think you might need to go back this weekend and watch this. All right, let's do the last couple of ones. Here we go. So this one is elimination. This one's different. Elimination, you don't want a letter by itself, okay? So what you're looking for, guys, is you're looking for the easiest way. The easiest way to graph is when what letter is by itself. Why? The easiest way to do substitution is when any letter is by itself. The easiest way to do elimination is when you have the same number with the same letter. You might want to write yourself a note on that. Elimination, you want the same number with the same letter. Make yourself a note of that. Same number with same letter. So you've got, what numbers with the M?
Just the one.
1. And what numbers with the M here? 7. Are they the same number? No. All right, what numbers with the N here?
1.
Negative 1. What numbers with the N here?
2.
Positive 2. They're not the same. So you got to make them be the same. Do you want to make the M's the same or the N's the same? Doesn't matter.
N.
You want to make the N? All right, so you've got, don't worry about signs. You've got 1 and you've got 2. How do you make 1 become 2?
Add 2 or add 1.
Multiply.
Oh. Multiply
By 2. There you go. But here's the thing. If you multiply by 2, you got to do it to every single one of those numbers in that equation. Because if you do it to 1, you got to do it to all of them and make an equal. And I didn't do anything to the bottom one, so I'm just going to bring him over. So this is called elimination. And now I have the same number with the same letter. Y'all okay with that? So how do I make negative 2 and positive 2 eliminate? How do I make them become 0? You would add them. Very good. And if you do it to 1, you got to do it to all of them. So you got 2m plus 7m, which is 9. Negative 2 plus 2 is 0. I don't have to write 0, though, because I've got something there. And then I've got negative 18 plus 9, which is negative 9. Divide, and you get negative 1. Whoa. So you got 3 different equations to look at. You got your first 2, and you got the one where you multiplied. Which one do you want to use? It doesn't matter. The very first one? All right, so we've got m minus n equals negative 9. So you have negative 1 minus n equals negative 9. Add that 1 over. Negative n equals negative 8. Divide by that negative 1, you get positive 8. So what's your order pair?
1 8. Negative 1 8.
How'd you know that? Alphabetical order. Perfect, perfect, perfect. All right, y'all try number 2. Well, let's do 2 together. Sorry. All right. What are the numbers with x?
2,
Okay.
8, and 3.
Okay. Are they the same?
No.
All right. What are the numbers with y?
4 and 6.
Are they the same?
No.
No. So you got to make them be the same. It doesn't matter which one you pick. I personally would like to pick x because they have 2 smaller numbers. But which one would y'all like to do? Don't pick the one that I want. I just like that because it's smaller. Is that y'all okay?
Yes.
That's the same reason y'all have? Okay, so 2 and 3. What number does 2 and 3 both go into? So how do I multiply 2 to make it become 6? 3, you sound like a robot. Then how do I multiply 3 to make it become 6? 2. So you gotta multiply everything by 3 and everything by 2. Thank you. I was like, why in the world can I not do math all of a sudden in my head?
Are you concussed?
I'm like Sawyer. I know I'm concussed. Yes. Bless his heart. That's nothing to joke with, y'all. Those things are serious. Equals 6. Okay, multiply 2 times 3. Yep. Y'all okay? Alright, so y'all wanted to do sixes. How do you make 6 and 6 cancel out?
Subtract.
You subtract. So this would be 0. Now here's where you have to be careful. You ready? This is where it always gets you, right here. This is 12 minus negative 12.
So you add it.
That would be 24. You would add it. Yep. This is 54 minus 6.
48.
There you go. Are y'all okay?
Would we have also just left it like that to where it would have done 6x equals 48?
Can we just like not like just like combine the x's and then got rid of the y's?
That's what I just said.
Yeah, you could have added.
That's literally
You
what
could
I
have.
just said.
You could have added, and then you would have gotten rid of the y's, and you would have had 12x.
Yeah, and then I got.
Yes. Yes. That's not what you said. You said 12x equals. And I was trying to figure out where you got 12 from.
Oh, yeah, it's
Okay. Yes, I see that now. I just didn't realize that's what you were talking about. All right. So divide, and what do you get for y? 2. All right. So now I got to plug it back in. I have 4 different equations.
I found the x. Okay.
Yeah, you just got your answers backwards. You found x. Now you'll plug it in and find ry. And then, so it's the same thing.
Okay, now.
Which one do y'all want to do?
X.
Well, yeah, we have to. Which one do you want to plug it into? You want to do the 2x? Okay. All right. So 2x plus 4 times 2 equals 18. Oh, bless you. Okay. All right. So that's 8. Oh, Jesus, that was funny. Okay. Subtract the 8. What do we get? 10. And so, Ethan, did you get 5 for your x? Yeah. So you just got your answers backwards.
I was like,
Yeah, it's the same thing. Alright, so that would mean that if you were to graph those two, they would cross at that point. Are y'all okay?
Yeah.
Alright, we're going to do one more together, and then the rest will be for homework. And while you're working on your homework, I'll pass out your tests so you can see them from yesterday.
Oh, great.
Oh, yes. They were actually very, very good.
Like, was mine an A?
I don't remember.
No.
I don't remember. I graded them so fast I can't remember. Alright, let's do number 3. Here we go. Number 3. You actually could do this with substitution, or you could do this with elimination. But because it said use elimination, we got to follow the directions. So do you want to get the x's or the y's? We'll do the x's? Okay. So I've got to make these become the same. So I'm going to multiply this by 2. Don't worry about any signs. So that'll be 4x minus 2y is equal to negative 8. And I'm just going to bring the bottom one over. So how would I eliminate the 4x's now? You would add them. Very good. And 4x plus negative 4 is 0.
Oh, no.
And negative 2 plus 2 is 0. But negative 8 plus 6 is negative 2. Are those equal?
Yeah, no.
No solution.
Dang it.
So if we were to graph those, what would those look like? They would be parallel, which we'd call
Independent. No, dependent.
inconsistent. All right, so your homework tonight is 4, 5, 6, and 7. You've got 5 minutes that you could be working on them now and at least get 2 of them finished. And I'm going to hand out your test to you. Lucy, I have your quiz to get back to you as well. How long do you have to do test corrections?
1 week.
1 week.
Hey, I just figured out how number. I just
You might
figured
cook
out.
yourself.
Cody, you want to see this?
I'll do more than that.
Are you going to cook yourself?
Look back and you can be back in your
Yes.
You don't get to just leave twice. Where's that? There you are. Yeah.
I hate looking at it.
Crap. I need to get coffee during lunch. Yeah, I want it. Right. Now,
Speak, Elizabeth.
Put it out.
What?
We're getting a different thing, but the same thing. I don't understand.
Probably Wednesday.
You know you're still
So
recording.
they'll give you either Thursday or Friday.
Okay. You want these back?
Yeah, I need these back. Oh yeah, I probably should pause it, but it'll be alright.